Within this section, we're going to start learning basics of Python programming language. So if you know already about Python, if you have studied Python before, you can of course skip the sections directly into the Mac changer writing section. But if you have doubts about Python or if you have never studied Python before, I suggest you go one by one because we're going to start from scratch and learn all the details that we will be needing about Python when we write ethical hacking tools. Now, if you're ready, let's get started.
Hi! Within this lecture, we're going to officially start writing our first Python code. And we're going to work with notebooks, so I'm going to create a new notebook from here. And remember, I'm going to save my notebooks and share all of them with you in the GitHub. But I really recommend you to not only watch me and take notes, but also write your own code at the same time within the Jupyter notebook. I'm going to share this with you anyway, but just use them as references and try to write synchronously with me so that you can practice and learn it better. So let's create our first notebook, and let me zoom in a little bit so you can see it better from here. And I'm going to change the name of it. So I'm going to give numbers to my notebooks, and this is just for me to track the notebook so I can share with you properly. Don't worry about the numbers. I will share every notebook after each individual lecture. So if you don't want to name this with numbers, you're of course welcome to do that. And I'm going to name these variables. That's what we're going to talk about a little bit in this lecture and the following lecture, okay? I'm going to rename this notebook as variables, and I will start to write my code. So in the previous lecture, when we first actually installed the Jupyter notebook, we have written some print arguments, right? Like print hello world. But if that was the first time that you have encountered with programming, maybe you got confused. Okay, why are we printing? Why are we just writing some things and getting some outputs? Actually, the programming is like that. Like if I type 5 plus 6 and hit run or shift enter, I got output of 11, right? So Python actually makes this calculation for me. If I just want Python to print something, it will print something. If I just Python to calculate something, it will calculate. I write code and Python just take cares of the rest and does this stuff for me. So if I want Python to go to the internet and download me something, it will do so, and we will learn how to do that in future, of course. But the general idea is that we want to sum like 1500 and 494, it will sum. Okay, so as you can see, we can do the basic math. Like if I divide 900 by 7, it will just divide and give me the exact number of it. Of course, we can do the other operations as well, like multiplication or deduction, like 500 minus 200, or let's do some multiplication, so 120. So it's correct. So there are other ways to just make this easy for us. Like what? So for example, if I want to multiply 2 by 3 times, what do? Of course, you write 2 multiplied by 2 multiplied by 2, and it will give me 8. But there's a shortcut to do that actually. And it goes like this: 2 star star 3. It means that 2 to the power 3. Okay? Of course, in this case it was simple. But if I wanted to just multiply 2 by 9 times, it would have been much simpler for me to write it like this. So I get 512 as an output. So, other than this, what can we do with Python in mathematical equations? There is a thing called remainder, for example. If I divide a number by another number, what is the remainder of that dividing operation? So if you divide 10 by 2, what do you get as a remainder? 0, correct? Because 2 times 5 is actually equal to 10. So let's try this with Python, and remainder is shown as percentage. So it goes like this: 10 percent sign and 2 shift enter, it will give you an output of 0. So let's do another example like 11% sign and 2, it will give you 1, of course, because the remainder of 11 divided by 2 is actually 1. Let's do another example, 11 divided by 3, so the remainder will be 2, because 3 times 3 is equal to 9 and 11 minus 9 is equal to 2. So the remainder is 2. I hope you know about these general simple mathematical concepts. This is very helpful when you want to find out a number is either an even number or an odd number. For example, if you get the remainder of it and it returns 0, then it means that it's an even number. Okay, enough for the mathematical operations. Now let's talk about different kinds of numbers. So as you can see, we had this decimal number in here like 0.5. Okay, if I just multiply 0.5 by 3, I get 1.5. So we call this kind of numbers floats and integers. Okay, so integer is a whole number. It doesn't have a decimal, so it's like 1, 2, 3, 6. And the other kind of that we were talking about was float. So 1.5 is actually a float, 0.4 is actually a float. If I just multiply these two floats, I get out of a float which is 1.20. And don't worry about this 0.0002 decimal thing. It is related to how Python actually interprets the decimal numbers. It won't cause any messy thing in your calculations, but it will just change the decimal and in a little minor way. Okay, but this is what you should know. Whole numbers are integers, decimal numbers are floats, and they are two different kinds of data in Python. Okay, so if some function, if some code expects you to give an integer, you should give a whole number. If on the other hand it expects a float, you should give out a float. So maybe it doesn't make sense to you right now, but it will as we move along. All you have to do is just now understand that integers are whole numbers, whereas the floats are numbers with decimals. Now we're going to stop here, and within the next lecture we're going to introduce a concept called variables, so that we won't have only predefined values but also changing values as we move along with the code. Okay, since now we know about the integers and floats, let's dive into the variables. So we cannot go on with predefined values all the time, because we may want to change the numbers as we go along. Because why? Because maybe you need an input from the user, or maybe you need an input from the internet. Okay, so you're going to download a number and store it into a variable. So we store some values into the variables so that we can reuse them anywhere anytime we want, and we can change them afterwards in anywhere, anytime we want when we try to code. Okay, so we are multiplying 0.5 with 3 in this case. Maybe this number will need to be 4 at some point. Maybe you're dealing with a user age number. Okay, so user age will increment in along the way. So we don't want to just write 3 or 1 or 1 million in a single code most of the times, but rather we want a variable. We want a value that we can store those numbers into, and we want to change it or we want to reuse it in anywhere we want. So let's do this. What I'm going to do, I will just sum 3 and 5 together. And then later on, let me mark down this and write variables in here and hit Shift Enter. Let's do this with variables. Let's say that x is now 3, okay, and y is equal to 5. Now, whenever I call x, I get the value of 3 in my code. Whenever I called y, it will give me the number of 5. So if I type x plus y, it will give me 8. For example, if I want to x to the power y, it will give me 3 to the power 5. Okay, so as you can see, now I can use x and y in the code whenever I want. So I defined x as 3 in here. So if I want to change this value, can I do it? Of course I can. Now I can say x is now 4. And from this point on, x is now 4. If I just say x plus y, it will give me 9 instead of 8 anymore. So whenever I change the value, from that point on, the value is 4 actually. Let's do an example about this. Let's say we get an input of radius of a circle from the user, and I want to find out the circumference. Okay, and as you know, the circumference is 2 pi r, the radius. And how do we get the radius from user? We call a method called input. Okay, so if you type input and open a parenthesis, it knows that it has to ask for an input. If you just print, okay, we used the print methods before, right? So it printed out something, and as you can see, it shows in green. It means that it's a built-in Python function, okay, Python method. So input is something like that, and Python knows it has to ask for a user input in this case. So if you say r is equal to input of something, it will ask for an input from the user, and it will just set the r value to the user input. And whatever you write in here within quotation marks, it will display as a message when asking input. If you hit Shift Enter, it will say r is, and this is where the user actually gives the input. For example, let's give 5, and now r is equal to 5. Now if I want to just multiply r 2 and 3.15, 14 for example, and 314 is pi actually. As you can see, we get an error, okay? It says that can't multiply sequence by non-int type of float. So when you get an error, what do? You got the error message here, right? So if you don't know what this means, what you can do, you can copy this and open Google, okay, and just paste the message here and hit enter. And most probably you will end up with a website called Stack Overflow and any other resources for Python as well. Let's go into Stack Overflow and let me zoom in a little bit. As you can see, Stack Overflow is a great website where developers share the solutions with each other. So you ask a question and people try to help you for free. And there are tons of questions that are asked before, so there is a pretty good chance you will find whatever you are looking for. Okay, so for example, I found out the same error message that we are getting in Stack Overflow, and if you go down, if you go below, you will see it has 6 valid answers, and people are trying to help each other and trying to make people understand the problem. Okay, so of course you can browse the other questions, other resources from Google as well. And don't worry, I will explain what this problem is in a minute. But for general programming purposes, I really suggest you to look for Stack Overflow results in Google and try to understand the error message that you are getting. Okay, so let's go back to our code, and the problem is here is that R is not an integer or a float. Actually, R is actually a string, and whenever a user gives an input, it is stored as string, a text. We didn't see strings yet, we will see in the next lectures, but just know that they are basically texts. Okay, so how could I know that? If I had written type and pass x as an argument, it will give me out an integer. Okay, so if you want to learn about type of some variable, you will just say type x. And let's, for instance, define our pi number 314 in a variable, and if I type pi, it will give me float because this has decimals and x is 4, so it's an integer. So let's try r in this case. So if I just call r, it will give me 5, but see, this has quotation marks. So this isn't actually an integer, this is a string. So if I type r and hit shift enter, it will say that it's a string. So how can Python multiply a string with a float? So if you want to just multiply Jack, for instance, with 5, maybe you can multiply it because you can just write Jack 5 times. But you cannot write Jack 3 and a 5 times, 3 and a 3.14 times, okay? So it doesn't make any sense. So if I want to multiply x and pi, it's okay because they are both numbers. But in our case, we need to make sure that 5 is stored as a number, not as a text, because we don't have capability to multiply texts by numbers, especially with floats. Okay, and we will see that in detail in the following lectures, but for right now, know that you have to store this as an integer. And in order to do that, I will create a new variable called r underscore int, and this will be integer version of our r string. And in order to do that, I will just write integer r, okay? So this is known as casting, and if I call rint right now, it will give me 5, and if I call type rint, it will give me integer. Now I have an integer and I can find my circumference in that was my point in the first place, right? So now I can multiply r integer with x and with pi without getting any errors. And please note that this is known as casting. We casted the string to be an integer. So let's try to multiply all of this together and we get the final result. Okay, so now we have learned about storing values into variables. We learned about different types of actually numbers and different types of data structures and what can or what can't we do with them. Don't worry at this point because we're going to learn much more about them in the future, but I just wanted to show you a preview. Now in the next lecture we're going to see how we can download and open these Python notebooks. Hi, as I said before, I'm going to share all these notebooks with you so you can compare and have a reference when you try to write and learn about Python. Okay, I'm going to do that over a site called GitHub. So GitHub is an amazing site if you want to share or collaborate on a code, programming language, okay? And I'm going to include the links after each individual lecture, so don't worry about the link now, but they will be all stored in a file called Python course. Okay, so if you open that link, you will find that all the IPYNB files, that is Python notebook files, are stored into this folder. So whether you can just click on one of them and open it, or you may want to just clone and download all of it and open them with your own Jupyter notebook at any time. Okay? And again, I repeat, I don't recommend you to download everything and just follow the course with my own notebooks. You have to create your own notebooks in order to practice, in order to write the code. So let's do an example. What I'm going to do, I'm going to just click on my link. It's already clicked and opened in here. You find out the link and open it yourself. If you just hit here and download zip, it will just take all the files and zip it together and download it your own computer. Now you're ready to just open that zip file and unzip it, and from the Jupyter website, from the Jupyter local server, you can find where they are located. So they are my downloads folder, and let's see, Python course, for example, if I click any of them right now, it will pop open, right? So let's click on variables, the very one that we have been working with. So it's now opened. But when you first open a notebook, the cells, the values, will be in a state that they have never been run before. So we define some variables in the cells, okay? We define some values, we write some codes, but they have never been run. So at this point, it says that x is 3, but this cell isn't actually run. In order to run that, remember, we need to just hit run or shift enter. But you cannot just do that with all cells. So if you go cell here and click on run cell, it will do that for you. And you can click on run all below in order to run and make sure all these things are in line. So if you want to open a cell between cells, you can go edit here and say split cell, and it will pop open a new cell for you. And if you want to delete it, you can just click delete cells from here as well. And actually that's it. Now you know how to work with GitHub files. So let's stop here, and within the next lecture we're going to continue with our data structure types, mainly texts that are called strings in most of the programming languages. Hi, as we talked before, now we are done with the variables part. We're going to learn how to work with strings that are texts in this lecture. So I'm going to save this notebook and I'm going to close it, okay? Because I'm going to create another one in which we will have the strings. Of course, if you want, you may continue with the first variables notebook as well. So let me zoom in a little bit more so you can see it clearly. Now we're going to work with strings. So make sure the code is selected here and let's write our first string. Our first string will be hello world as usual. So I'm writing a string and I'm hitting shift enter after that, and as you can see I'm placing it into two double quotes. And if you place it in the single quotes, it will be okay as well, okay? But I always prefer double quotes actually, because if you try to write something like I'm a pilot, for instance, okay, the second single quote will be closed and the rest of the code won't be interpreted by Python, okay? So if you hit shift enter, it will say invalid syntax because Python doesn't get after the second single quote, okay? What I can do in order to overcome this problem, I can wrap this into double quotes and I can still use the single quote inside a string. So I generally prefer double quotes when working with strings. You may choose whatever you please, okay? So this is a string, and of course we can assign strings to the variables as we did in the previous lecture, okay? Like x is equal to hello world. If I hit x, it will just give me the output of hello world. Can I change the string? Of course. Now I can say x is equal to hello only. And if I hit x again, it will give me the output of hello. And in Python, we can do something that we cannot do in the other programming languages generally. We can say x is now 3, okay? Now x is a number rather than a string. If we did that in Java or another programming language, it should have complained us and said that you cannot convert this into an integer because you define it as a string. But in Python, we can do that. It's a very flexible language. Of course, this may create a problem as well. Think of this case. You initialized a variable as a string, and then you convert it to a number, and then you change it back to a string, and then we're going to learn some other data structures as well, like Boolean and stuff. We can change it to whatever we want. But at a certain point, we may get lost, and we may want to know what kind of a data structure we're dealing with, okay? Then we have a method to know what kind of type of variable that we are dealing with. So let me say x is hello world. Again, now x is string, as you know. If I type x, it will give the output of the type of x variable. By the way, let me show you a length method as well. So if you type len x, it will show you how many characters you have in your string, okay? So let me mark down it. Let me write it down as a note so you can memorize it better. So if you type len x, it will count the characters in a string and give you as an output. And it will just include the spaces as well. As you can see, it has 10 characters, but including space, it has 11 characters. So it gives out 11 as output. So len and type are spatial methods that we can use with strings, and we can use with most of the variables, most of the data structures as well. So maybe you think, is there any other function, special built-in function like that? Yes, there is print function like we seen before. If you type print x, it will just print out the hello world, the current value of the variable x. Okay, so we have len, type, print. Of course, we have other special methods as well. That's what we're going to learn in future, but for right now, let's stick it to strings. Okay, so let me talk about special escape characters. So before we go on and write print, let me mark it down and say escape characters as a note to you. Okay, so what are escape characters? So what if I want to split a string into two? Okay, so let's say I want to write inside a print method hello Python. Okay, but rather than having a single line, I want hello at one line and Python in the down. Okay, so if I write like this and hit shift enter, as you can see, we get an error because we cannot do that. In order to create a new line, there is a special syntax that you should follow. All you have to do is do a backslash, okay, not a forward slash, but a backslash like this, and type n as a new line, okay? If you type \n and hit shift enter, as you can see, it writes hello and Python on separate lines. Now let's put a space and hit shift enter and see what happens. Python will be still on the separate line but with a space. So if I undo it and hit shift enter again, now it is the exact output that I want to get. So are there any other special escape characters? Of course. So if I want to give a tab between hello and world, I will just have to write \t. Okay, as you can see, it just creates a tab space between hello and Python. So at this point, actually you may think that these are just texts. Why are we spending too much time on them? Because we're going to use them when writing ethical hacking tools so much, I want to emphasize the importance of them. In the next lecture, we're going to see some advanced methods of strings as well. Okay, now we are done with the basic operations of strings. We're going to now move forward to advanced operations since we are going to use them when writing ethical hacking tools. So I'm going to use another notebook as usual. I'm going to close this and create a new notebook called Advanced Strings. If you please, you can continue with the previous one, of course. I'm going to zoom in a little bit and I'm going to change the name to Strings Advanced for this operation. Okay, so I'm going to rename this and let's start. First, I'm going to create a variable called myString and it will be equal to hello world as usual. So we have learned to call the strings, like I can call myString and it will give me the output of hello world. But we didn't learn how to get a single element out of my string, a single letter. Okay, so let me write this as a note. So I'm choosing markdown and putting two hashes here to specify that I'm going to use this as a heading, and I will say indexing. Okay, so what is indexing and how can we use it? So if I write my string and open a parenthesis but a square one, not a regular parenthesis, okay, not a curly parenthesis but a square one, and after that if you write 0 for instance and hit shift enter, it will give you the first letter. So why first letter? Because indexes start with 0 in strings. And indexes generally start with 0. We're going to learn something called lists. Maybe you have heard them as arrays in other programming languages, but in Python we call it lists. And indexes always start at 0. So suppose you want to get O out of hello. How do you get it? I suggest you pause here and try to get the O yourself. I hope you managed to get it. Since O is the fifth element, I will just say 4 and it will give me O. Why? Because index starts at 0 and index 4 is equal to the fifth element, which is O. Okay, so I hope you get the general idea. You can use indexes to get individual elements out of a string. So suppose you want to get the last element rather than the first element. What do you do then? You may write -1 in here, okay? And -1 means the last element. Of course, if you try to just get the -2, it will give you the second last element of that string, which is L. So it is pretty useful when you want to get the last letter of a word, last letter of a sentence. I don't know, we will use them when writing ethical hacking tools. So we have more complex methods than this, surely, and let's see about them. We want to know something called slicing, okay? So there comes a time when we need to get a specific portion of that indexes, like we want to get the elements between 2 and 5, or up to 5, or from 5. What do we do then? We need to know a concept called slicing. Let me create another string called myString2 and give it 1, 2, 3, 4, 5, 6, 7, for example. And please pay attention that I'm surrounding this into double quotes, because if I written it like this, it means that it's an integer, but I'm not gonna work with integer, I'm going to work with a string, so I'm surrounding it with double quotes. So this is our string. Now, if I write something like this, what will I get? The first element of that string is 1, right? So it's pretty clear, I think, right now. But what if I want to get a certain proportion of that string? I would have then used this colon sign and say 2, for example. Let's hit Shift Enter and let's see the results. What we get here is that 3, 4, 5, 7, and so on. So what does it do? It just omits the first 2 elements of that string. Okay, it starts with the second index, so it just omits the 0 index, first index, which is 1 and 2, and starts with the 3. So this is called slicing. Okay, actually let's delete this because these irregulars are not a markdown cell. Let me write it down as a note, so I'm choosing markdown. I'm going here to specify this will be a heading with hashes and say this is slicing. So let's move on. So what do I mean by slicing? I can specify which index I'm going to stop or start with slicing, with using colon, of course, like we did in this example. So what if I want to just get 5, 6, 7, 8, 9, 10? So I can write my string with colon, of course, and I want to omit index 0, first, second, third. Okay, so I will just start with 4, and it will start with the fourth index. So I will have 5, 6, 7, and so on. So the first number before the column specifies the starting index. And if I type something like this, my string 2 and 2 after the column, it means a stopping index, and it says that stop at index 2. So it just gives out the 1 and 2, the index 0 and the index first. Okay, so you might think that when we specify the fourth here, it just included the fourth index, and when we specified the second here, it just didn't include the second index. And that is exactly what Python is trying to do actually. It doesn't want any intersection. So the first one is starting index, it includes the fourth, and second one is the stopping index, and it doesn't include the stopping index. So I can get the first part of a string in a separate way and the second part in a string in another way. Okay, so let's write it down. Okay, with a hash again, it's a stopping index. So if I write down my string second, fourth this time, I will have get what's left of this 5, 6, 7, 8, 9, 0. So I can get 1, 2, 3, 4. So this is the logic behind including one index in one method and not including it in another index. Okay, so is it possible to use them both in the same line? Of course. When I type 2 colon 4, it means that start with the second index and stop at fourth index. So it will start with the 3 and it will stop at 5, right? So let's hit Shift Enter and it will tell us 3, 4, and it will stop at 5 but not include 5, so we will get 3 and 4. So we can get middle of a string, we can get the top and bottom of a string, we can get starting point, ending point, middle point, some portion with using slicing techniques. So always remember that the first one is the starting index, but second one is actually a stopping index. So what if you want to get something like 6, 7, 8 as a number? So pause the video here and try to get it yourself. If you did get it, very good. If you didn't, you should have written 5 to 8. Because why? So the fifth index is actually the 6, and it starts with the starting index, and the 8th index is 9. It won't include the 8th index, so we will get out as 6, 7, 8. So this is how you work with slicing. But we're not done yet. We have something called step size. Okay, let me write it down for you, and it will specify how many sizes that we are going to skip when we are working with slicing. What do I mean with it? Let's write down our my string 2, and if I type 2 columns this time and hit Shift Enter, it will give me my string as it is, because I didn't specify any starting, stopping index, and the last part before we close the parentheses is actually the stepping size, and we didn't specify any stepping size either. So what if I did? So let's see an example. Let's say colon, colon, and for example 3. So it will just skip 3 steps when it gives out the output. So we get 1 and we just skip to the third index, okay, after 1. So we omit 2 indexes in the middle. So we can for example, we can say my string colon colon 2 and we only get these odd numbers, for example. You're going to find this very useful when you deal with complex set of strings, and you can combine all of these methods into one single line. What do I mean? You can say start with second, stop at fourth, and step size is actually 2. So it will give you only the 3. So it turns out that only 3 fits in with our current filtering. Of course, you may want to do some other complex examples as well. I really suggest you guys to just work around with this, play around with this, and the final trick is using -1 as step size. If you use -1 as step size, what will happen? It will just reverse the string. Okay, so this is pretty useful. When you want to reverse a string, you can just give the -1 as a step size. -1 doesn't make sense to use as a step size, but this is a trick in Python that we use. So we're done with the strings here. Let's move to the next lectures where we will learn other data structures as well. Hi, within this lecture we're going to learn about some attributes and methods of variables. So let's start by marking down and saying hash hash and string methods, for example. Okay, if I hit shift enter, it will create a new line for me. So within this new line, I will create a variable and I will show you some options, some attributes, some methods of that variable. Let's suppose it's my name, and I will create a string called Atil. That is my name. You can do it your own name, okay? So let's say my name dot. If you place dot, it will show you the respective attributes of that variable. But in Jupyter Notebooks, it doesn't show you directly. You have to click on tab or shift tab on your own keyboard. If you click shift tab, it will give you some description, okay? If you click tab, and I just placed shift enter rather than clicking tab on my keyboard, so let's delete this cell from here and let's write it again, my name dot, and hit tab, and it will open the different options, different attributes that you can change actually in this variable. And this is a long list. Let's choose the first one, capitalize. And the capitalized means that capitalizing the first letter, and my first letter is already capitalized, so let's make it smaller and hit shift enter again. If I run capitalize right now, as you can see, it just capitalized my first letter for me. Let's call my name again, and let's call it properly, my name again, and as you can see, this is now not capitalized. Even though I asked for it to be capitalized, it returned me the output, but it didn't change the original one. So what do I do? If I want to store this capitalized thing again to reach out again in another code, for example, I can create a new variable called my name capitalized, for instance, and save it to my newly created variable, right? So let's hit shift enter again and let's run this as well. Now if I call my name, it won't be capitalized, but if I call my name capitalized and hit Shift Enter, it will be capitalized. So it may sound confusing right now. Why didn't it change the original one, but why did it give out a new one? So I will explain this later on in future lectures where we'll deal with functions. But for right now, let's go and see other options, other attributes that we can play with. Okay, so if you hit dot and hit tab again, you will see some other options. Let's find another one. Let's work with split, for example. And in order to work with split, let's create a new variable or change our variable to two words actually, till Sam, for instance. Okay, you have to have two words in order to make split work, because it will split this, and I will show you how. Let's choose split from here, and if you choose split and open parentheses again and hit Shift Enter, it will split it into two words. Okay, and this is now actually a list, but I'm not gonna go over what is a list right now. But as you can see, if I call my name again, it will come up as one word. But if I want to save this to another variable, I can of course do that. My name split is equal to my name dot split. Now if I call my name split, this comes out as a list. So you don't know lists, you will learn in the following lectures, but you can reach out each single element in a list. So if you want to get a till, for instance, you may want to say 0, and if you want to surname, you may want to say 1. And this is indexing, okay, like we did in the strings section as well. So I think you get the idea that variables have attributes and methods, and you can call them just by adding a dot afterwards and hitting tab and choosing whatever attribute, whatever method that you are looking for. Okay, and let's do some more examples, but let's do that with integers this time, because every data structure has its own attributes and methods, of course. So let's create a my number, which is 1 2 3. Okay, and this is an integer, not a string, so don't place it in quotation marks. So let's see this options in here. As you can see, there are much less attributes and methods compared to strings. Okay, so you may want to try this. You may want to do some options from here as well, or you may want to go to the previous example and try to do some other stuff from strings as well. I really suggest it, like upper. Let's do upper, and you will see it will upper all the letters in a string. And the general idea is, how do I know all the attributes or all the options? Of course, I don't know all of them, okay? And where should I get information about it? If I go my name dot and choose a method or an attribute that I'm curious about, like split, then if I hit Shift Tab at this point, it will give me some description like we did before, right? So in here I can see the doc string. This is documentation string, which explains how this works. So it says that returns a list of the words in a string. Okay, so I can see how this works, how these methods and attributes work by hitting Shift and Tab in here. but this is specific to Jupyter Notebook. So let me show you another thing. If I go to Google and search for Python docs or Python documentation, it will pop open this 372 documentation for me. Okay, and this is official Python website. So let me zoom in, not zoom out, and this is official Python website, so I can search for whatever I want and find detailed information about it. So let's suppose that I want to work with strings, and as you can see there are some versions in here, and you may want to learn about versions or general Python. Whatever you want, you will find it here, trust me. But for example, I want to learn about strings specifically. Then what do I do? Then of course I can go to search in here and search for strings, right? So let's search for strings. It will list some options for me. I will choose the first one and I will see the string class or string variable in here, and I will see the attributes, methods, and I can find whatever I'm looking for about strings in here. So if there comes a point that you cannot find or you're not certain what to do, or which attribute you want to get or which method you want to choose, you may always go here and read about it. One of the best things about Python is that you have a lot of resources on the internet, and that is why Python is very popular, so popular at these days, and you have to take advantage of this. Okay, you have to read the documentation, you have to search for libraries and modules and packages, and don't worry, we will see what they are in the future, but you have to read and understand each word, because unlike other programming languages, Python has very proper, decent documentation in here. So let's go back to our example and see some other things that we can do with strings for the last time. So what if I want to combine mathematical operations with my strings? For example, if I want to multiply James by 10 by 10, can I do it? Of course, if I hit Shift Enter, it will print out James 100 times. But remember, when we deal with integers and floats, we couldn't multiply a string with a float, right? And yeah, we cannot do that because it doesn't make sense to have a 10.5 James. Okay, so it won't multiply. Even if I delete this and hit Shift Enter again, it won't do it, and I get the same error that we got before. But if I want to multiply it by 10, then it's okay, because it makes sense, it's logical. It will just write James 10 times. So what else can I do with strings? Do you think we can sum? We can add some strings to another? Of course we can do it, but we cannot sum a string with an integer, right? So it doesn't make sense. Let's try to do that with James and 5. It says that it must be a string, not an integer. But if I convert this string into this integer into a string by surrounding it with quotation marks, if I type Shift Enter right now, I will get James 5. So it actually adds the strings together. If I type James and Lars, it will give me an output James Lars. So it may come in handy, right? Let's suppose that you have a name and you have your surname as well. So let me type mine, C, and Shift Enter. So if I want to get my full name right now, I can add my name and my surname together. and this is very helpful. Let's run it. So it added, and let's call my full name, and I will see my name and my full name. What if I want to have a space in here? Of course, I can do that. Shift enter, shift enter, shift enter, and I will have this space. Or I could have, let's delete this and shift enter, and in here let's add a space, actually a string, which is a space which contains a space, and then shift enter, shift enter. Now I have the same result. So other than that, can I divide a string into 2 or into 5 or 7, for example? Let's try that. Let's say my name or James divided by 2. Of course it won't work because it doesn't make any sense. All you can do is to multiply it. So we're done here. Let's stop here, and within the next lecture we're going to work with lists. Hi, within this lecture we're going to start learning about lists. So I'm going to create a new notebook from here, and as usual I'm going to zoom in a little bit so we can see it better. And let me just rename this as lists so we can go on and start learning. Actually, we did some kind of introduction to list before. What we did was creating a string like my string is equal to until, and if we did my string 0, we called the 0th first index. Okay, so this was the first element, and if we called my string 1, it gave us the second element. So this is how actually string works, and this is kind of how lists work. But we couldn't do that in string. If I do my string 0 is now something else, it won't accept it, because strings cannot be changed this way because they are immutable. Okay, so let me write it down for you. Immutability. So you cannot change this. So if I do my string 0 or 2 is equal to right now another letter, for instance, it will give me error message. So let me comment this out by putting hash on these lines and hit shift enter in order to run this again. So this will be like a note rather than code. Okay, so we couldn't change strings in that way because strings are immutable in this sense. But let me give you an example of a list. So in order to create a list, open a parentheses and square one again and write your list inside, like 1, 2, 3. So now if you do something like my list and get me 0, it will give me the first element of that list. So it's pretty much like working with strings, right? And if I do something like my list 0 is now equal to 5 or 3 rather than 1. Now if I call my list, as you can see, it says 5, 2, 3. So lists are mutable. You can change the individual elements inside a list, and strings are immutable because you cannot change the individual characters. So let me do one markdown again. So this is mutable. Okay, you can change the single elements inside it. So if I do my list 2 is now 6. If I call my list again, it's 5, 2, 6. It's completely changed. So let's see some attributes or methods of that list. So if I say my list dot and I hit tab, I see the options, I see the attributes and the methods. What I'm gonna do, I'm gonna append something to the end. Okay, so I'm going to add another element to that list. You can use the first option in here, first option in that list, and it's called append. Select it and open a parentheses as usual, and insert the element that you want to insert, like 7. Now if I call my list, it is going to be 5, 2, 6, 7. So maybe you realize something was different this time. In the string section, we have seen some methods and we have seen some attributes, but it was kind of different. Maybe you remember that if we call a string like my string is Lars, for example, if I say my string dot capitalize, it will be Lars, right? But it won't change the original string. So this is my string again. So the L is not capitalized, but when I do the append, it actually changed. So if I call my list, again, it's not 526, but it's going to be appended, like with 7, right? If you call this time, you will get 5267. So this actually changes the original one rather than returning a new string or new object. In the old-fashioned way, we had to give a new object, new variable for this, like my string capitalized, remember? So we had to do that in order to store Lars capitalized. But this time we didn't have to do that. So this returns the original one appended. And you're going to understand this more in depth when we deal with functions and methods in the following section. But for right now, you see some kind of methods where in a way they behave when we choose them. Okay? So, for example, let's see another method. MyList.tab, it will give us some pop option. And give a parentheses and hit shift enter, it gives the last element, as you can see, the 7. But what it's actually done to pop this element off that list. So if we call my list, as you can see, is 526. So this last element is popped out. Again, this behaves in a way that it changes the original object. So, can we have lists as mixed data structures, like integers and strings in the same list? Of course we can. Let's do that. My mixed list is equal to like 1, 2, and A, and I don't know, B, H, F. Okay? As you can see, it gives us no error. So if I call my list 0, it will give me 1. And if I call my mixed list, and this time -1, and remember -1 gives the last element and it's a string. And if I call like this, it won't pop out, so it will just give me the last element as an output. So we can have different data structures in a list, and we don't know the booleans and other data structures yet, but we can have them together mixed in a list. And you don't have that kind of flexibility in other programming languages actually, but Python does have it. So in other programming languages, you either have an array or a list of strings, or array or a list of integers, but in here we can have a mixed list or an array, whatever you want to call it. But in Python we call it lists. So let's give you another example, like my list1 is equal to A, B, C. Let's suppose I have another list called my list2, and it does have D, E, F. Can you think of a way to mix this together? Of course, we can do my list3 is equal to my list1, and that is summed with, as you can see, it gives us recommendations as I type my list, like my list1 plus my list2. If I run this with shift enter, it will just sum these two together. Now let's call my list tree again. As you can see, this is now summed up and as unified as one. So can we multiply list? Yeah, of course, like my list 1 multiplied by a tree. So it gives us my list 1 3 times. So we see this kind of flexibility in all areas. But we cannot do something that logic doesn't have its sense. Like we cannot do this, okay, my list 1 plus 5, because it doesn't make any sense to sum this. But we can multiply. Can we multiply it with a float? No, we cannot, because it doesn't make sense to have 5.3 times my list 1, right? So this has the same principles that we have talked before in the strings section. We can multiply this with an integer, but not with a float. So can we do it like this? My list dot and say reverse, and it will reverse the all array for us. Of course we can do this. Now this is reversed like CBA. The original one is ABC, and if you go here, we have seen that my string that capitalized returned this but didn't store original one. So if I do my list 1, this is now stored in the original one as well. So this is CBA. Again, this doesn't return a new array, it just manipulates the old original one. So lists are very important, so we're going to spend a little bit more time on it. So within the next lecture we're going to see some advanced methods and attributes as well. Hi, since we have learned about the fundamentals of the lists in Python, let's dive into some more in-depth subjects regarding that. So what we're going to learn about first is called nested lists, okay? So if you have heard the nested before, it means that it's a term stating that it's something inside of something. Like a nested list is actually a list inside of a list. So let me give you an example, okay? So let me put a mark down here saying that this is nested list, and this goes like this. Let's suppose we have a list called new list, okay? So my new list is going to be equal to, open the square parentheses and say like 1 4, let's have a string in here, okay? So if I want to add a list inside of that list, can I do it? Of course we can. You can either use the append method, or you can just assign a new value to it, and like you can say new list is again like 1 for A, but with this time with a new list inside a list, and inside that we have 3 and C. So let's say shift enter, and now our new list actually equals to this, okay? So let's suppose we want to get the list inside of that list. How do we do it? Like we can say new list, and this is 0 1 2 3, right? This is the third index, fourth element. So if I say 2, it will give me A, and if I say 3, it will give me the nested list. So this is going to be 3C. So if I want to, I can just assign this to be another variable, like nested list is new list third, okay? So if I hit shift enter, now my nested list is equal to a list of 3 and a C. As you can see, it gives out the list inside of a list. So let's suppose I want to get the C out of it, so I can say nested list 1, right? But actually there is much simpler way to accomplish this, accomplish reaching out C. what I have could done is just to use the new list with two indexes in order to get to the C, like new list 3, and it will give me the nested list, then 1, right? So it just calculates the third index and then the first index of that array. So since it returns an array, it can find the first index of that nested array as well. So this is one of the areas that we see Python is really flexible compared to the other programming languages as well. So you cannot do that in other programming languages, most of the other programming languages. So let's see another example. Let's suppose we have our list again, new list, and can we do that slicing thing that we used to do in the strings? Like getting some proportion of it, or using starting point or stopping point. Of course we can. Like I can say 2 colon and empty. If I hit shift enter, what will happen, do you think? Of course it will start at the index 2. It will get me from 2, okay, from 2 until the end. So this is A3C. So if I say new list colon 2 this time, it will give me up to 2, and it will stop at the index 2, so it will give me only 1 and 4. So we can use the slicing thing in lists as well. I believe you now see the resemblance between the strings and the lists, and remember, we're going to use lists a lot when we deal with ethical hacking part as well. Now let's save this, and in the next lecture we're going to learn something called dictionaries. Hi, within this lecture we're going to learn something called dictionaries. So I'm going to create a new Python notebook from here, and let me zoom in a little bit so we can see it better. Now we are ready to learn. Actually, in the previous sections we have learned lists, right? And dictionaries are actually some kind of lists, but rather than having a single element, this has more than one element. So let me rename this as dictionaries, so we are ready to start. So as I said, dictionaries don't have a single element, but actually a pair. So let me show you how to create a dictionary first. So my dictionary is equal to not a square bracket here, but a curly braces, okay? So this is curly parentheses. This is how you create dictionaries, with a curly parentheses, and you have to give it a key, like here, okay, key, and with a colon value. So dictionaries are actually a pair of key and values. So what do we do with that? If you call my dictionary and with a parentheses and a square parentheses, okay, not a curly one but a square one again, my dictionary key, if you write key here, you get back value. So this is how dictionaries actually work. And in what sense we can use them? This is the real question. Let's suppose you have a list like my list, and let's suppose that you want to create a fitness list like 100 calories for running and 200 calories for swimming, for instance. So you can write 100 and 200 inside of a list, right? But you don't know what 100 and 200 stand for in this case. So maybe you know from your head, like you have it memorized, but you don't know it. So maybe you create a new list, and inside that list you specify the first element as run and the second element as swim. But you don't know, you don't actually combine them. So maybe you come up with an idea that my list 0 is 100 and my list 20 is running. So if I get 2 zeros out of 2 arrays, 2 lists, then I can match them. Okay, but this is not useful every time. So you need a system where you can pair each other. So this is where dictionaries come into play. So you can create a MyFitness dictionary, and with a curly braces you can say running with a colon 100 and swimming with a colon 200. Okay, so now if you call MyFitness dictionary and maybe you realize that I hit tab after I have written MyFitness and it auto-completed, and if I call run it gives me 100, and if I call MyFitness with a tab it auto-completed, and swim it gave me 200. So now I have a system where I can pair a key and a value. So dictionaries are pairs of keys and values, but can we have like strings or integers or other data structures as keys and values? Okay, of course we can, and this is one of the flexible things about Python as well. You can have as many as you like in a dictionary. Okay, as many data structures, data types as you want in a dictionary. So let's give an example, and let's create another one in order to not confuse with the previous one. Let's suppose we have a dictionary called My Dictionary, and 2 is now curly braces, key 1 is actually 1, key 2 is actually 2, and key 3 is now not an integer, but this time it's going to be a string, okay, like apple. So if I hit shift enter, as you can see, we get no error. So if I say my dictionary 2 and open a parenthesis and say key 1, it's going to give me 1. But now if I say my dictionary 2, okay, if I say key 3, it's going to give me apple. So in the first one I got out an integer, and in the second one we got out a string. Okay, so we can use data structures like mixed, like we did in the lists. So it has actually some common points with lists as expected. So let's create a new dictionary called My Dictionary 3, and let's open our curly braces, and this time I'm going to write some key 1 is with a colon is equal to 10, and again let's write something with not a string as a key but an integer as a key. Can we do that? Of course. Like if I call my dictionary 3 this time, and if I say key 1, it's going to give me 10. But I can do that as well, my dictionary 3, and rather than saying key 1, I can say 20 and it gives out 30. So not only in the values but also in the key side we can use data structures mixed as well. So in other programming languages, most of the time you have to specify same kind of keys like strings or integers, but in here we can use strings, and then in the second element maybe we can use integer as a key. So this is very flexible again. So let's have another example in here, like my dictionary 4 this time, and let's say with a curly braces the key 1 as usual is 100, and key 2 is equal to, now this time, a list. Can we do that? Of course we can. Now let's say key 3 is actually another dictionary. Can we do that? Of course. Dictionary inside a dictionary. So this has a key of A and the value of 5, for instance. So can we get to key 1, key 2, key 3 separately? Yes. And can we do a nested call like we did in the previous lecture? Of course. And we're going to do an example of that in a minute, but first let me show you a method, an attribute or a method of a dictionary so you can understand it better. So if you do something like this, my dictionary for, and you have to get all keys of my dictionary for. In an example, what can you do? There is a method to do that actually. If you call my dictionary for, it gives out the whole dictionary for you. But if you call my dictionary for dot keys, for example, okay, and like we see all the attributes and methods when you hit tab, like if you call the keys with a parenthesis at the end, if you hit shift enter, it gives you the dictionary keys. So you can see the keys here with this method. Can you get the values? Of course, you can do my dictionary for dot, and if you go to the bottom you will see the values. So I can call the values and see the integer, the list, and the dictionary as well. So let's do an example. Like I said before, let's try to get the key 3. Okay, and what is the key 3? It's the dictionary. And after that you have to get the 5 out of it. And please pause the video and try to get it yourself. I hope you managed to get it. And this is exactly the same thing like we did in the nested list. If I do my dictionary for key 3, it gives me the new dictionary, nested dictionary. And if I do A in here, it gives me the 5. So I can reach dictionary inside of a dictionary with a single line. So if I do something like this, my dictionary 5 for this time, so this is our last example, like key 1 is 1 and key 2 is again 2. Okay, if I hit shift enter, this is now a dictionary. Now if I want to change this, I can do something like this. Key 1 is 1, okay, but I don't want it to be 1 anymore, but rather I want it to be 3. Can I do this? Of course. If I call my dictionary 5, as you can see, this is key 1 is 3, key 2 is 2. So you can change the elements, you can change the values afterwards. And what if you want to append a new item to the dictionary? You don't see the append method anymore in here, but this is actually simpler compared to list. You just specify the new key and you specify the new value in here. So it's automatically appended to the dictionary. So if I call my dictionary 5 now, I will see all the key and the values with the appended one. So now let's stop here, and within the next lecture we're going to learn about something called sets. Hi, since we now completed the subjects of lists and dictionaries, now I'm going to create a new Python notebook and I'm going to rename this as sets. So that's what we are going to learn within this lecture. So sets are collection of data structures like lists and dictionaries. But in sets you cannot have an element more than one time, okay? They have to be unique. So we didn't see that in lists, right? So let me create a list for you. So my list is equal to 1, 2, 3 and 1 again. So we have 1 2 times, right? So if I call my list, I will see 1, 2, 3 and 1. And let me turn this into a set, and I have to see just one time in that set because set contains unique elements. So let me do some casting. Actually, we have done this before, right? So we had said int to just convert a string into an integer. So if I say, let me just mark this down for you. So this is casting, okay? So if I say I want to convert my list to be a set, so set parentheses my list. So this converts my list to be a set. So if I call my set, let me show you what we get. So I have 1, 2, 3, and I don't have that second one because they have to be unique in a set. So what can you do with a set? If you have a list with duplicated items, you can convert it to be a set and you can just get rid of these duplicates. So let me create a new set for you and show you how to do that. So you have to use these curly braces and just type the elements that you want to be in. So let me type 1, 2, 3, and 1 again, and let me call my set 2, and it's still going to show me 1, 2, 3 because it will just omit the second one because they have to be unique values. So let me call type this time to see what type my variable is. This is a set. So in sets you have unique elements. So let me do another example just to make sure that sets are working the way that we want. Let me create another one with a string this time. So this is ABA, shift enter, and if I call my set 3, then I will see only A and B. So you have the possibility of including strings, integers, and everything like we used to do in lists and dictionaries as well. So it's kind of a dictionary in a way that we define it with curly braces, but we don't have key and value pairings in here. We only have elements as we have in lists. So sets are just like this, and let me show you something else. So we already created lists, dictionaries, and sets, and we always gave the initial values when we create them, right? So we said that my set is 1, 2, 3. But what if we don't know the initial values? So can we create an empty list? Can we create an empty set? Yeah, of course we can. But why do we want to do that? Maybe we are just downloading from the internet. Maybe we are getting data from some other class, some other program, I don't know. So maybe we have to initialize this as an empty list. So my list is going to be an empty list, just like this, okay? So square braces here, and this is empty. So if I do type my list right now, I will see this is a list. But if I call my list, it will just pop out an empty list. So if I say my list append, now I can append the data that I got from anywhere. So I can say my append, my list is 1. So I can append as many as I want right now. So if I create a set, for instance, my set 4 this time, I can do this. So empty curly braces. So I can say my set 4 and it will pop up an empty set, okay? And if I just verify this, type my set 4, this is a dictionary. And as you can see, it says that this is a dictionary because it can be a dictionary and a set, okay? So if I don't give this, I can give this, right? I can have key value pairings here, or I can just have single elements. So Python confuses if I wanted to create a dictionary or if I wanted to create a set. So I don't know how to deal with this at this moment right now, right? So what can I do to make sure that I created a set or a dictionary? There is a way to do that actually, besides having these empty curly braces or empty square braces at all. So I can say key 1 is 1, then my set 4 is going to be definitely a dictionary. But at this point, maybe I just wanted to create a set, and the proper way to do this actually, my set 5 is going to be a set with parentheses. So now I definitely have an empty set. This means that I have created an instance of a set class, and we're going to see what it means in the future. So if I call my set 5 right now, it shows that it's an empty set. It's definitely a set, not a dictionary. So I can say my set 5 dot add and add whatever I want to add, like 1. So this is my set 5 dot add like 2. Okay, let's say my set 5, and it will give us 1 and 2. And if I say my set 5 dot add 2 again, and if I call my set 5, it will only show me 1 and 2 just once. So my set 5 is definitely a set. So we can use this thing in other examples as well. Like if I want to create my dictionary 2 to be an empty dictionary, an empty instance of a dictionary, so this will be a way to do it. So I can say my dictionary 2 key 1 is now 1. And if I call my dictionary 2, I will see the key value pairing of key 1 and 1. And can we do that with lists? Of course, my list 10 is equal to a list. And now I can append anything I want. Let me call type my list 10. This is a list. And if I call my list 10, this is an empty list. And I can say my list 10 dot append and insert any value that I want in here, like a. And if I call my list 10 dot append to, then it's all included in the list, like append I don't know, another list. And if I call my list 10, it will be all displayed to me. Now we know about sets, and now we know how to create empty dictionaries, lists, and sets as well. So let's stop here, and we got a couple more data structures as well, and we will see them in the next lecture. Hi, within this lecture we're going to cover something called tuples. So I'm going to create a new Python notebook from here, and let me go and change the name to tuples. And I've heard people pronouncing this as a tuple or tuple, so you may choose whatever you want, okay? But I call it tuple. So what is a tuple? Tuple is a list-like object, okay? So dictionaries, sets, or list-like objects, but they have some similarities, they have some differences, and I believe you have understood them in the previous lectures. Tuples are like lists, but they cannot be changed after they are initialized, okay? So they're immutable too. So let's suppose we have actually a list, like my list equals to like A, 1, and C, for example. So what could I do in the previous lectures? I could have said my list 0 and it's going to be A, but I could have changed it, right? So my list 0 is now B. So if I call my list, now it's B1C. So we could change the first element, but if I call my tuple, so you create tuples with regular parentheses, okay? So let me call the same thing A1C. And if I call my tuple with a square braces again, I can just say get me the first index, 0 index, and it's A. But I cannot do that. My tuple 0 is now B. As you can see, we get an error and it says that a tuple object does not support item assignment. So we cannot change this. So let me hash this out and hit Shift Enter again to make it into a comment. And let me mark down this immutability thing, immutable. So we cannot change the single element inside it, like we couldn't do that in strings as well, right? So if you cannot say my tuple 1 is equal to 2. So I believe you have now understood the difference between a list and a tuple. Maybe at this time you think that why would I ever use tuple when there are lists, right? So we can create lists in the same way and we can change them afterwards. So tuple actually imposes a restriction upon us, right? But we don't know what kind of data we get from other sources. So we're going to use a lot of external libraries when we deal with Python. And external libraries actually are one of the strongest areas of Python and one of the most popular reasons why Python is being often used by programmers, developers around the world. So we will use external libraries, and they tend to use tuples over lists because they don't want us to change the data that we have gotten from them, okay? Or at least without actually processing it. So we may get tuples when we deal with external libraries. We may get tuples when we deal with another SDK, software development kits, I don't know, libraries, modules, packages. So even if we don't want to use them, believe me, you will just come across with them a lot. So it's better to learn about tuples. So like tuples has a count method, and if you just run it, you will get an error saying that count takes exactly one argument. So you have to give it an argument to work with. So what argument do we have to give? You have to give an element like A. So it counts the A inside a tuple. So if you want to learn count of a specific element, you use that. Let me give you an example. Like my tuple 2 is now 1 1 1 and A and I don't know, C. Okay, so if you say my tuple 2 dot count, and if you give 1, it will give you 3 because we have 3 ones in my tuple 2. So if you say my tuple 2, as you can see, we have an index. So it gives the index of a specific element as well. So if you say A, it will give 0, 1, 2, and 3. So A is located at the third index. But we have more than one ones here, right? So if I say my tuple 2 dot index 1, what will it give? So it will give the first index it encounters the specific element. So it's 0 for us. Yeah, it's located in the second index as well, but it just says the first location that is found. So let's stop here, and within the next lecture we're going to learn something called Boolean. Hi, we are at the last lecture of this section and we're going to learn something called Boolean. So I'm going to create a new notebook from here. I'm going to change the name to Booleans. So Booleans are actually the easiest topic to cover, and there is a reason why I just left it to the end. So they are either true or false, and it's written like this with a capital T and F, okay? So you cannot say true with a lowercase t here, okay? So let me create a new variable called my Boolean and make it equal to true. So why do we need Booleans? They are either true or false. They are two basics. Why in the world do we need them? So we will have so much logical flows and controls within the next section, okay? And we just need them when we are dealing with programming. So we need to check if something is bigger than this, or we need to check if something is smaller than this, or we need to check if something is equal to another thing. Okay, so we're going to deal with this kind of flows and controls very much. So this is one of the essentials of programming. And let's suppose that you're creating a game and you need to know whether the character of yours is alive or dead, for instance. Best way to do that is to create a Boolean and track that Boolean, like is dead, is now false, for example. And when your character dies, you can just set this Boolean to be true, and if that Boolean is true, I don't know, maybe your program will do something about it. So they are very basic, but they come in handy when we deal with real life problems in here. So we're going to see some logical operators within the next section, as I said, but let me give you a sense, a hint of it. So this is greater than, this is less than, and this is equal to. Okay, so you know this from basic math. So maybe you can say 5 is greater than 3, and it will give you true as an output. Okay, so like it gives 5 plus 3 is equal to 8, and if, I don't know, 3 is greater than 5, this is false. So Python just interprets this like a math equation, okay? So you can say x is 5, and maybe you want an input from the user of y, okay? And you know how to get input, right? You just use the input function. A user gives the input of 6, for example. Now the y is 6, but remember, this is just a string, okay? So if I say type y is string, I have to convert this into an integer. So I will say y int is now integer casting off y. So I have a y integer right now, and if I call type y integer, this is an integer. Now I can say, I can see actually if x or y int is greater. So y int is greater, and it gives us the true. So maybe this is vague to you right now, but within the next section, we're going to deal with the logical flows and operators. Then it will make very much sense to you. Just trust me, and let me stop here actually, and you're ready to go to the next section where we're going to learn about this controlling stuff.
Hi, within this section, you have learned about Python data types and structures, and you have learned a lot of information. So we have gone over numbers, variables, notebooks, strings, lists, dictionaries, sets, tuples, and Boolean. So if this is the first time you're dealing with programming, this information may be overwhelming for you. And I believe once you get to practice this information, it will make much more sense to you. So bear with me, stay with me, we're going to see a lot of details about Python in the following sections, but then we're going to start practicing Python by writing ethical hacking tools, then it will be clear on your mind. So let's move on to the next section.